Hello, everyone. It's bright and early, 6 a.m., and I was just so excited to do some algorithms. I just couldn't sleep. So I thought I would do a video on LeetCode number 3, longest substring without repeating characters. Let's read through the problem real quick. So given a string, find the length of the longest substring without repeating characters. So what are we trying to do here? So we have a string here, ABC, ABC, BB. And the output we should get is 3. And why should we get 3? Because ABC here, if you look, ABC, you have 3 characters here without having a repeating one, which is the 4th one here, right? A. So if it was this substring, then it would be invalid because we have 2 A's. So you could also have BCA, that would also give you 3. You could also have cab here, CAB, that would also give you 3, or ABC again. But after that, CB would be what you would get, or CB, and then the last part here would just be B. So there are multiple substrings within this string that would give you the output 3, but it's just looking for the maximum substring. So it's just representing it here as ABC, not specifically that this is the only substring you can get, but the longest possible one is 3. So here's another example. If you have a string full of just one letter, the output is 1 because B is the longest unique substring that we have. And then here, example 3, Q, Q, PWW, KEW. So you've got 2, then 3, WKE, and also KEW would also give you the value of 3. So this is actually a pretty cool problem. It's a sliding window problem, and it's the first one we've had. It's just the 3rd problem, but these are actually pretty fun problems to do. I like the idea of sliding window, and it's a technique that you can use on a lot of these types of problems when you're looking for values that are together within an array or a string. You would want to use a sliding window approach, and we're going to diagram out just what that looks like. I've done a little pre-drawing here, so as not to waste too much time. But what we have here is we have our string ABC, ABC, BB, and we're going to initialize 2 pointers. So we're going to have an end pointer, which is we're going to increment the end pointer every time. So we're going to use a for loop to increment this end pointer. So every iteration through the loop, we're going to increment our end pointer by 1. And we have a start pointer. So that's the start of the window. So E is the end of the window. S is the start of the window. And what we're going to do with the start of the window is every time we hit, we're going to track through the string. So to track the string, we're going to use a set. And I know a lot of people probably maybe haven't used sets or heard of sets, but sets are data structures that you can use that just track unique values. So if you have, say, you enter A, B, C into your set, and then you entered A into your set again, it wouldn't say that you have like 2 A's in your set. It would just say, oh, I already have A, my set is still just A, B, C. So it only tracks unique values. So it's perfect for this particular problem, or any problem really where you just want to know if a certain value exists within a collection of items like an array or a string. You can use a set to do that, and it has a few different methods on it. So a set has a has method, so you can say set.has, and it will be a boolean. It will return a boolean to you, true or false. You can also say set.delete, so you can remove a certain item from a set by saying set.delete. And then it also has a property that we're going to use to track the max length of our window, set.size. So set.size just says how many items do I have in my collection. So in this problem, at any point in time, the number of items we have in our collection is going to be the size of our window. So what we're going to do is we're going to increment this pointer. So right now we're going to say A, okay, we're going to add A to our set. And then we're going to increment pointer here. And then we will add B to our set. And then we will increment the pointer again. And then we'll add C to our set. And then we'll get here and we'll say, oh, okay, so A is already in our set. So we need to do something here. So since A is already in our set, we need to move up our last pointer. But we're going to do a couple of things here. The first thing we're going to do is we're going to delete A from our set. And then we're going to increment the pointer. So, and what we're going to do is, the strategy we're going to use for moving this back pointer is while the value here, while the start of the window does not equal the front of the window, we're going to remove items from the set. So we're just going to shrink the size of the window. And we're going to shrink the size of the window until we get to the point where we find the character that equals the character at the front. And then we're just going to move the window one position in front of that item. That way we remove that duplicate. We find the duplicate and we just move the window to exclude that duplicate from our window. So now our window is BCA, and we'll re-add A to our set. And so I should have been actually incrementing the size here too. So at each point we're going to collect our size. So we'll initialize max as 0. We'll collect our size. So when we started it was A, and then it was B, and then it was C, and then we got to A, right? And we deleted a number from our set, then we re-added it. So our size is still 3. And for the max, we're gonna take the max of the current size and our current max, right? So we're gonna say, okay, what's the max between 0 and 1? All right, that should be 1. What's the max between 0 and 2? That should be 2. What's the max between 0 and 3? That's 3. We do it again. What's the max between 3 and 3? It's still 3, right? So we're going to update our max using our current size. And okay, so we're going to keep moving here. So we're going to increment this. Okay, we're going to say, oh, B is in our set. Let's delete it. Let's move our back pointer until it does not equal the front. So then we just move it one space. So now we're excluding this B from our window. So now our window is just CAB right here. And then we'll re-add B to our set. And then we'll update our size. So our size is still 3. And then we'll take the max of our current max and our current size, which is still 3. All right. So then we will increment to C. Let me just get rid of this line I drew. So increment to C, we do the same thing. Move the back pointer until it does not equal the front value. So we just need to move it one place to A, right? We wipe out C, we add it back again, and then we update our size and our max. Still 3, okay? And we'll do the same thing. Bam, B. All right, so B is in our set. Now we need to move the back pointer until it does not equal the front, right? So we move it 1 to B, still equals the front, but we need to wipe out A, right? So we just because we were on A here. Sorry, let me re-say what I was doing there. Okay, so first we need to move the back pointer. So when we move the back pointer, we wipe out everything that it's pointing at while we're moving it. So we wipe out A because it was on A. Then we move it to B, right? So then we need to wipe out B, and then we move it to C, and we're done, right? Because we just need to exclude this value because it equals this front value. We're just wiping out everything before it, and then we re-add b to our set. And now our size is 2. The max of our current max and current size is still 3. And then we move our pointer to the end here to b, and then we need to update our pointer until we exclude this value. So we wipe out c, move it to b, wipe out b, move it to b, add back b. Our size is 1, and then the max is still 3. So then we will, since we're done, we'll return 3 as our max, which is the answer to this problem. So let's see what this looks like in code. All right. So the first things we want to do is initialize our extra pointer, because we're using a for loop. We'll have our end pointer for our for loop, and then we want to so we have the end pointer is going to be the increment in our for loop, but we need a starting pointer too. So we'll create a starting pointer, and we'll just initialize it to 0. And we also need to create a set. So I'm going to try to be better about my my variables. So my constant length. So we can just initialize this as a constant, and we can say set equals new set. And then the last thing we need to do is initialize a max. So we'll just initialize max to be 0. All right, and then we'll just say this is just setting up our for loop where we're going to increment through the string. So we'll just say let n equal 0 for the length of the string. Okay, and then we'll increment it. Okay, so this is where we're going to use those properties in the set. So we want to say if the set has the value, then we want to move the back pointer, right? So we'll say set dot has the end of the string. So if the set has the end of the string, then we want to push up that back pointer. So while the starting index of the string is not equal the ending index of the string, we're going to move our pointer. So we want to delete the value that it's on. So we'll delete that value. Delete at the starting index, and then we want to increment it also. So this line here, so we're just deleting that value from the set, and then we're just incrementing our pointer. And then so that'll kick us out of the loop. But the pointer, when we get out of the loop, is still going to be pointed at like the duplicate value. So we just want to move it up one more spot. So we'll move it, and we also want to delete that value that it's on. So we just need to do basically this line one more time. So we'll delete string start, and we'll increment the pointer. So now we've just resized our window and squeezed out that that duplicate value. So what we need to do is we need to re-add the character that we deleted. So we can do set.add. So we're going to add the current character. So that would be the end pointer right? So this line right here, we just deleted the duplicate character that it's pointing at, and then we just add it back. You don't necessarily have to do this. You could probably not delete it, but I just thought for like the sake of consistency with how the algorithm's working, I would just delete it and then re-add it every time. And then we want to update the current max of the size of the set and the current, or the length of all the windows. So we just need to say max equals the max of the current max and the set size. So that property is set.size. And then we just want to return the max at the end. So let's just see how we go. So just to recap, we initialized a starting pointer, we created a set, and then we initialized the max to 0. Then we looped over all the characters in the string, over the length of the string, and we checked to say, okay, does this set have the current letter that we're pointing at? If it does, we need to move the back pointer. So we need to move the back pointer till it does not equal what we're pointing at the front. And then while we're moving it, everything that we point at while we're moving it, we delete it. And then we increment, and then we just incrementally move that back pointer up. It will finish off the front. If the front was A, and this value here, that pointer is going to be pointing at the same value on the back end. So what we want to do is we just want to delete that, bump it up one spot, so it squeezes that value out of the window, and we want to delete it, and then we just re-add everything here every time through. So if the set doesn't have the value, we just increment the end pointer, and we just add the value to the set. And then here we're just taking the max of the set size and our current max and returning it at the end. So let's see how we go. One of these days it's not going to work, but hopefully okay. Yes. All right. So let's see how we did. So let's. All right, nice. So this is, I would say, the most ideal solution to this problem. We can talk a little bit about the time complexity of this problem. I forgot to do that. And I also should be talking about the space complexity too. I kind of been forgetting to do that. So the first thing we'll address is the time complexity. So the time complexity of this problem is, you guessed it, order n, right? And why is it order n? So it's order n because we just need to loop through the string, right? And now we do have a nested while loop. So I guess you could say that this algorithm is maybe 2n. So like we basically kind of, in the worst case, we would loop through all these values, and then we also are kind of looping through them again. But like we said before, we ignore constants when we do time complexities, so we can just say that it's order n, because the size of the string is what's going to dictate the time that it takes for this algorithm to run. So what about the space complexity? I haven't really been talking about this, but the space complexity of this algorithm is also order n. So the reason why the space complexity is order n is because we're using a set here, right? And as you can see, we're cramming basically every single value into this set. You can imagine if this was just a unique string of characters, if every character here was unique, the size of our set would be the length of the string in the worst case. So that's why our space complexity is order n. My name is Ryan. This has been LeetCode number 3. What is it? Longest substring without repeating characters. I hope you join me next time when I solve LeetCode number 4.